War is often remembered by the thunder of artillery, the clash of armies, the names of battles etched into history. Normandy, Midway, Bastogne. But beneath the smoke and fire, wars are shaped by something quieter. Ideas. This is the story of the American inventions that silently altered the course of World War II. Not myth, not legend. Proven, historical, engineered by ordinary Americans whose names are rarely spoken, yet whose work changed everything. In 1940, the United States was not ready for a global war. The military was small, equipment was outdated, fuel, weapons, and aircraft production lagged behind the industrial might of Germany and Japan. Franklin D. Roosevelt called America the arsenal of democracy. But at the time, that was a dream, not a reality. Factories that once produced washing machines, typewriters, and refrigerators would soon be forced into a new life, building bombers, tanks, and ammunition. The auto industry alone converted more than 300 factories into war production. For General Motors, Chrysler, every assembly line became a contributor to the war. Roosevelt didn't simply ask America to fight. He asked America to invent one. Of the first breakthroughs, was so unexpected that it sounds like the setup to a joke. How did America help win the war? With a rubber shortage? When Japan seized Southeast Asia, the source of nearly 90% of the world's natural rubber, the U.S. military panicked. Without rubber, there would be no tires for jeeps, no gaskets for engines, no insulation for wiring. A military without rubber is a military that cannot move. In a crisis meeting, Roosevelt demanded, "Find a way to replace rubber fast." Enter Waldo Seaman, a polymer specialist working for B.F. Goodrich. Seaman wasn't a war strategist. He was a chemist. A quiet, meticulous man obsessed with molecules. In the 1920s, he invented a method to plasticize a brittle chemical compound called polyvinyl chloride, PVC. Before this moment, PVC was considered useless. Seaman looked at it and saw potential. He mixed the polymer with additives, pushed its tolerance, experimented with temperature and pressure. And in 1941, he succeeded. PVC became flexible, durable, and mass-producible. History might forget his name, but Seaman didn't just save the U.S. war effort. He helped create the modern plastics industry. PVC became essential. Insulation for wiring and aircraft, waterproof jackets for soldiers, blood bags for medics on the front. It replaced millions of pounds of rubber. Millions. PVC was never designed to win a war, but wars are not won only by courage. They are won by supply lines. Seaman's plastic kept them alive. Another invention wasn't a weapon. It was food. The K ration. Before the war, soldiers carried heavy canned meals that required heating. Slow, bulky, inconvenient. A U.S. Army physiologist, Dr. Ancel Keys, was given a challenge. Create a meal that weighs almost nothing, requires no heat, and keeps soldiers alive. Keys tested them on paratroopers, infantry, and even on himself during extreme physical activity. His final product was a small brown box that packed 3,000 calories, biscuits, dried meat, chocolate, and instant coffee. Soldiers joked about the taste. They complained. They cursed Dr. Keys by name. But when American paratroopers dropped behind enemy lines in Normandy and their supplies were cut off, K rations kept them moving. Keys later used his wartime research to create something entirely different, the Mediterranean diet, one of the most respected nutritional studies in medical history. He became one of the most influential nutrition scientists of the 20th century. He started with a soldier's lunchbox. Not all inventions came from scientists in lab coats. Some came from a pilot's rage. The Pacific theater was brutal. At sea, battles were fought across distances no soldier could see. American pilots faced kamikaze attacks. They needed to hit fast-moving ships without flying into the teeth of enemy fire, and that required a weapon unlike anything used before. The proximity fuse. The idea: build a shell that explodes not on contact, but when it gets near a target. Simple idea. Impossible execution. To do that, a miniature radar system had to be placed inside a spinning artillery shell fired at 15,000 rotations per minute, enduring heat, shock, and massive acceleration, then detect a target and detonate at the perfect moment. Most scientists said it couldn't be done. Enter Merle Tuve, a physicist from the Carnegie Institution. His team invented a tiny vacuum tube radio transmitter that survived launch, sensed when it was near a metal aircraft, and detonated. The first test shot down a drone plane on the first try. Admiral Lewis Strauss later said, "The proximity fuse won the Battle of the Bulge for us. It was so secret that soldiers capturing unexploded shells were ordered to risk their lives recovering them, rather than allow the enemy to copy the technology." Britain later called it one of the three keys to Allied victory, the other two, radar and the atomic bomb. And all three were driven, funded or engineered in the United States. Then came the bomber that shouldn't have been possible, the B-29 Superfortress. It was the most advanced aircraft of its time. Pressurized cabins, remote-controlled gun turrets, central fire control. Each B-29 contained over 55 miles of wiring. It cost more than the Manhattan Project to develop, over $3 billion in 1940s currency. The U.S. military needed an aircraft that could fly higher, farther, faster, one that Japan could not shoot down. It didn't come from Boeing alone. It came from America's manufacturing miracle. General Electric designed the remote sighting system. Westinghouse built components for the central fire control computer. Goodyear made fuel tanks. Fisher Body, a division of General Motors, built airframes. Detroit didn't just build cars. Detroit built the bomber that ended the war in the Pacific. And yet, one of the most influential inventions of WWII did not come from a factory. It came from a woman. Hollywood actress Hedy Lamarr and composer George Antheil co-invented a radio-guided torpedo system that used frequency hopping to avoid enemy jamming. They patented it in 1942, U.S. Patent 2002-92-387, titled Secret Communication System. The Navy classified it. They never used her invention in WWII. It would resurface decades later. Today, Hedy Lamarr's patent is considered foundational to Wi-Fi, GPS, and Bluetooth, and she never received a dime. During the war, the U.S. government told her, "You're too beautiful to invent. Sell war bonds instead." She sold $25 million worth of bonds, but her real legacy is inside every smartphone. The next invention didn't win headlines. It won battles. The world knows the M1 Garand rifle. Few remember the machine that built it. The U.S. adopted a manufacturing method called interchangeable parts, a concept perfected by Henry Ford during car production. Before this, rifles required fitting by hand. They were slow to produce and hard to repair in the field. Ford brought the assembly line to weapons. Manufacturing Springfield Armory and Winchester used that system to mass-produce the M1 Garand 700,000 rifles per year. General George Patton called it the greatest battle implement ever devised. American soldiers could fire 40-50 accurate rounds per minute, while German troops still used bolt-action rifles. War is not only decided by tactics. Sometimes it is decided by reload speed. But if the Garand helped soldiers win land battles, American radar helped them avoid losing the war entirely. Early radar was massive, fragile, unreliable. The U.S. needed something rugged, small, and accurate. The answer came from American laboratories. The cavity magnetron, refined at MIT's radiation laboratory. It allowed radar to shrink from building-sized installations to units small enough for aircraft and ships. A radar didn't just detect enemy aircraft, it predicted where they would be. British Prime Minister Winston Churchill said, "Radar is the invention that won the war." The magnetron made radar effective, and the magnetron was perfected in America. Radar changed how wars were fought. But to use radar effectively, pilots needed a way to navigate through darkness, storms, and combat without visual contact. They needed something more sophisticated than compasses and guesswork. They needed a way to see the unseen. The answer was LORAN, long-range navigation, developed jointly by the U.S. Coast Guard and the National Defense Research Committee. Using synchronized radio pulses from fixed ground stations, LORAN allowed ships and aircraft to calculate their position with accuracy, previously unimaginable. Before LORAN, a pilot flying at night over the ocean was effectively blind. After LORAN, American bombers could fly hundreds of miles through clouds and darkness and still hit their targets. By 1944, more than 75% of all U.S. naval vessels carried LORAN receivers. A new concept emerged: precision warfare. But navigation alone could not defeat Germany or Japan. America needed to protect its troops, even before they got to battle. Thousands of American soldiers were dying during amphibious landings not because of enemy fire, but because of the ocean. Waves flipped landing craft. Steel boats sank. Dozens drowned while still wearing gear. They needed something that could do the impossible, drive like a truck, float like a boat, carry soldiers unharmed from ship to shore. American engineers at General Motors created the WWII amphibious truck, a 31-foot-long steel vehicle that could drive directly off transport ships and straight onto beaches. Soldiers nicknamed it the Duck. General Dwight Eisenhower later said, "The WWII was one of the most important pieces of equipment we had. Without it, the invasion of Normandy would not have succeeded. They moved supplies where trucks couldn't. They crossed rivers where bridges didn't exist. They rescued stranded sailors and crashed pilots. They turned coastlines into doorways. But invention does not only happen in laboratories. Sometimes, it begins on a sketch pad, drawn by hands that are both brilliant and stubborn. In 1940, when Europe was burning, a man named Donald Douglas began working on an aircraft Americans had never seen before. A plane so large that people joked it could cast its own eclipse. The C-47 Skytrain, derived from the civilian DC-3 airliner, it was modified into the first true military transport aircraft. It dropped paratroopers over Normandy, hauled wounded soldiers out of combat zones, delivered food and ammunition to Bastogne during the Battle of the Bulge. It wasn't glamorous like a fighter. It didn't rain destruction like a bomber. It delivered something far more powerful: mobility. A single C-47 could carry 6,000 pounds of cargo or tow a glider carrying jeeps and artillery. More than 10,000 were built. Paratrooper veterans often say, the war was won on the back of the C-47. Airborne warfare was born not through strategy, but through invention. Some inventions existed on the bleeding edge of science. Some existed on the edge of insanity. Young Navy lieutenant named Edward Ellsberg suggested a concept for small underwater demolition teams and precursors to the Navy SEALs. To destroy underwater obstacles, these men needed tools that could work submerged. They needed underwater breathing systems, demolition charges, waterproof fuses. American engineers invented waterproof blasting caps, miniature time charges, the Mark V diving suit. These inventions allowed demolition teams to clear the Normandy beaches before the invasion. Without them, thousands more Americans would have died. Meanwhile, in the Pacific, another invention emerged, not as elegant, not as technological, but effective. It was called the LVT, Landing Vehicle Tract, built by the Food Machinery Corporation. Yes, a company that once built canning machines for vegetables now built amphibious assault vehicles for war. The LVT crawled out of the sea like a metal reptile, its treads clawing through coral reefs and mud. Marines used it to storm island after island: Tarawa, Saipan, Peleliu, Iwo Jima. The Japanese had machine guns, mortars, artillery. The Marines had LVTs. Machines designed for farming fed the war. But tools and weapons were not enough. America needed something else, something that could not be mass-produced information. In 1942, a young electrical engineer named Claude Shannon, the father of information theory, helped develop one of the earliest secure telephone systems, called the Sigsilly. This machine encrypted conversations between Franklin Roosevelt and Winston Churchill. Each Sigsilly weighed 55 tons. It used speech encryption based on random noise, a concept that eventually led to modern digital encryption. Roosevelt and Churchill never knew the technical details. All they knew was this: the enemy was listening, and Sigsilly prevented them from hearing. But even encrypted transmissions needed boots on the ground. Communications are critical, but language can be a battlefield. The U.S. Marines turned to a group of Americans whose language was not known to the world: the Navajo Code. Talkers, their spoken language was so complex that it had no written alphabet. Within weeks, 29 Navajo Marines created a code that classified military concepts. Hummingbird meant fighter plane. Turtle meant tank. Chicken hawk meant dive bomber in the Pacific. Navajo code talkers transmitted 800 messages at Iwo Jima. None were ever decoded by Japan. Major Howard Connor said, "Were it not for the Navajos, the Marines would never have taken Iwo Jima." Sometimes, the most powerful invention is a language. America's next breakthrough came from desperation. Early in the war, depth charges dropped into the ocean to attack submarines. Huge explosions, massive sound, stunning visuals, and almost no hits. German U-boats slipped away in silence. To hunt submarines, the U.S. needed a new weapon. Something guided, something precise, something intelligent. The torpedo needed eyes. Harvard electroacoustics pioneer Dr. Robert J. Urich helped develop passive sonar tracking, a system that let torpedoes listen for propeller noise and chase submarines automatically, and worked. U-boats that once hunted American convoys now became hunted themselves. Technology turned the ocean from a graveyard into a battlefield Americans controlled. Meanwhile, in factories across the United States, another invention took shape, one so massive, so ambitious that it stretched beyond the limits of imagination. The Liberty. Ship simple, ugly, unremarkable, and unstoppable. American engineers designed a standardized cargo ship that could be built faster than German submarines could sink them. Henry J. Kaiser, a construction contractor, pioneered a new process of welding ship hulls instead of riveting. Result? Shipbuilding time dropped from 200 days to 4 days. At peak, the U.S. produced a ship every 3.5 hours. Germany simply could not sink ships fast enough. Liberty ships, delivered. Tanks, planes, ammunition, soldiers, fuel, food, everything. An army marches on logistics, and America invented logistics. Back in the laboratories, American chemists worked on something else, a compound with no color, no smell, no taste, yet capable of saving thousands of lives. Penicillin, originally discovered by Alexander Fleming in 1928, it was American scientists at Pfizer and Merck who made industrial-scale production possible. They used deep tank fermentation and corn steep liquor to grow the mold by the tens of thousands of gallons. The result? Battlefield infections that once killed wounded soldiers stopped. The mortality rate from infected wounds dropped by over 80%. A soldier hit by shrapnel no longer faced death by infection. Penicillin turned injury from a death sentence into a second chance, and then the world changed forever. A secret city in Tennessee, another in Washington State, a third in New Mexico, the Manhattan Project. At Oak Ridge, engineers used electromagnetic isotope separation. At Hanford, workers produced plutonium through nuclear reactors. At Los Alamos, scientists, led by J. Robert Oppenheimer, designed and built the first atomic bombs. The project employed 130,000 people, yet remained secret. Factories ran 24 hours a day. Entire towns appeared out of nowhere. Workers were told, "Your job is not to ask questions." On July 16, 1945, in the desert near Alamogordo, New Mexico, the invention became reality. A blinding light, a shockwave, a world forever altered. Oppenheimer whispered words from Hindu scripture. "Now I am become death, the destroyer of worlds." America had invented the ultimate weapon. But the war was not won by a single invention, it was won by thousands. Each with a purpose, each with a story. From plastics that replaced rubber, to radar that guided planes, to amphibious vehicles that conquered beaches, to penicillin that saved the wounded. America didn't just fight, America engineered victory. War is a machine with limitless hunger for fuel, steel, ammunition, and above all, movement. America's inventions were brilliant, but none of them mattered if equipment and soldiers could not be moved efficiently. In the war's early years, moving material across the country was slow, unreliable, and chaotic. Railroads jammed, trucks clogged highways, and critical shipments became stuck. The U.S. needed an invention not made of metal or gunpowder, but of ideas. That invention was logistics. General Brehon B. Somerville, head of the Army Service Forces, believed that the war could be won not only with weapons, but with supply lines. Under his direction, the United States developed standardized packaging, barcode-like labeling systems, and rail priority codes. Every crate had a code. Every truckload had a destination. Every box was part of a system. Logistics became an invention. Ford Motor Company applied the moving assembly line to munitions production. General Motors did the same for engines. Factories didn't adapt to war. Factories became war. Meanwhile, in a place no one expected, another invention was forming. One that helped America determine enemy troop positions, artillery locations, and aircraft movement. The SCR-584 radar, a compact, mobile radar system with automatic tracking. Unlike earlier radar systems, which required operators to manually track objects on screens, the SCR-584 used automatic electronic tracking once it locked onto a target. One engineer joked, "It's a radar with a brain." It was used to guide anti-aircraft guns with deadly accuracy. During the Battle of the Bulge, SCR-584 radars shot down V-1 flying bombs that screamed toward London at 400 mph. Before SCR-584, hitting a V-1 was like trying to shoot a bullet with another bullet. After SCR-584, the odds shifted. Technology turned the sky from a threat into a hunting ground. While radar watched the skies, another invention conquered the ground, one that every American GI loved more than any rifle or truck. The Jeep. Willys Overland and Ford co-produced it, based on a requirement from the U.S. Army asking for a light, nimble, powerful vehicle. Mechanics nicknamed it the Swiss Army knife on wheels. It could transport troops, mount machine guns, pull artillery, act as an ambulance, or traverse terrain that would swallow other vehicles. General Eisenhower said, "America could not have won World War II without the Jeep." More than 600,000 Jeeps rolled into Europe and the Pacific. British soldiers, amazed by its ability to climb slopes, coined a phrase, "The Jeep goes where the devil fears to tread." It wasn't glamorous. It didn't fire bullets, but it moved an army. Another invention changed how Americans crossed oceans. The Navy needed something nimble enough to dodge torpedoes, fast enough to attack enemy positions, and cheap enough to build in massive numbers. A young boat designer named Andrew Higgins, a tough and loud shipbuilder from New Orleans, invented the Higgins boat, LCVP, landing craft, vehicle, personnel. His company wasn't a major defense contractor. He designed boats for logging and shallow water operations. But his design had one secret weapon, a front drop-down ramp. This allowed soldiers to charge forward directly onto a beach, rather than climbing over the sides. Eisenhower said, "Without Higgins' boats, we could not have landed on Normandy." Hitler knew it too. He called Higgins the new Noah. More than 20,000 Higgins boats were produced. Factories in New Orleans worked day and night. Women, students, retirees, black and white workers earning the same pay, rare in the 1940s South. It wasn't just an invention, it was a social revolution. Not every invention destroyed, some inventions saved. The blood plasma program, pioneered by Dr. Charles Drew, an African-American surgeon and medical researcher, revolutionized wartime medicine. Drew designed refrigerated blood storage portable plasma containers, long-term transport systems. The U.S. could now collect blood, process it into plasma, store it, ship it overseas, and give it to wounded soldiers almost anywhere in the world. Plasma saved lives from shock and blood loss. Dr. Drew's work led to the American Red Cross Blood Bank. Did not receive full recognition during his lifetime, but soldiers lived because of him, many thousands. In the air, another invention gave American pilots an invisible shield. German anti-aircraft guns fired shells with deadly precision. The U.S. needed something to disrupt enemy targeting, a countermeasure that could confuse radar-directed weapons. American scientists called it window. Today, we call it chaff. Small strips of aluminum foil released from aircraft. German radar saw thousands of phantom targets. Gun crews didn't know where to aim. Entire air raids slipped through enemy defenses like ghosts. The simplest inventions are sometimes the deadliest. A piece of foil saved lives, yet there was another American invention that redefined the war. Not because of what it did, but because of how many could be made. Mass production of aircraft. At Ford's Willow Run factory, the largest factory in the world at the time, Ford engineers designed an aviation assembly line where a B-24 Liberator bomber rolled off the line every 55 minutes. Not per day, per hour. Henry Ford's philosophy took flight. Victory is the ability to produce faster than your enemy can destroy. Every hour, another bomber. Every hour, another machine that could strike deep into enemy territory. Germany could not compete. Japan could not compete. Industrial genius became a weapon. But invention was not just about the obvious. Not every American breakthrough was metal or explosive. Some were invisible. Inside the Office of Strategic Services, OSS, precursor to the CIA, American scientists developed mini cameras disguised as cigarette
case, explosive coal, Black Joe, delayed fuse sabotage.
devices, insecticide powders that dissolved machinery bearings. They called it the dirty tricks department. One invention stands above them all. The M1 4-inch Liberator pistol, designed by the U.S. Army Joint Psychological Warfare Committee. A crude single-use pistol, cheap to produce, 1 million made, dropped behind enemy lines. Given to resistance fighters, 1 bullet to kill a soldier, then take his gun. Sometimes invention isn't elegant. Sometimes invention is survival. But while OSS invented ways to break machines, another American engineer invented a way to protect men. A young inventor named John Browning and engineers at Colt developed the M1919 Browning .30 caliber machine gun, the backbone of American infantry. It was reliable in mud, sand, snow, and rain. Unlike German machine guns that jammed in harsh conditions, the Browning could fire 400, 600 rounds per minute without overheating. It didn't win battles alone, it kept soldiers alive long enough to win them. Then came a weapon too strange to believe, the proximity fuse, the fuse that exploded shells when they approached a target, instead of on contact, was already revolutionary. But American engineers wanted something even more advanced. They perfected the VT radio fuse, a miniaturized radar system sealed inside artillery rounds. Imagine firing a shell into the sky and having it explode at exactly the right distance from enemy aircraft, automatically. It was first tested by the U.S. Navy in 1943. The effect was immediate. Where American ships once used hundreds of shells to bring down a single aircraft, now it took only a few. When German infantry attacked in waves during the Battle of the Bulge, proximity-fused artillery detonated above them, raining steel fragments downward. German survivors reported the sky turning into a ceiling of explosions. Technology became terror. And yet, one of the most forgotten inventions wasn't a machine, it was training. Before the war, American soldiers trained with wooden rifles and makeshift weapons. The U.S. lacked ammunition to waste on practice, so 2 inventors, Frederick Atwood and Carly Swibilius, developed low-cost training ammunition that used lighter powder charges and simplified construction. Suddenly, soldiers could train realistically without consuming critical ammunition. The difference between fear and confidence is practice. In 1943, deep in New Jersey, a building was sealed with guards. Inside, Bell Laboratories engineered something that would change aerial warfare: the ANAPQ-13 airborne radar bomb sight. It allowed American bombers to hit targets through clouds, at night or without visual sight. Pilots didn't need to see. The radar saw for them. Germany tried jamming it. Japan tried outrunning it. They failed. Radar-guided bombers by night, production-guided bombers by day. America was relentless. There was still another invention waiting, arguably the most important invention of the entire war. Before the atomic bomb, not a weapon, not a machine, a process. A system of research and development collaboration between universities, corporations, engineers, and government. MIT, Bell Labs, DuPont, GE, Westinghouse, Boeing, RCA. Never before in human history had science and industry united with such precision and speed. Scientist Vannevar Bush, chairman of the Office of Scientific Research and Development, coordinated it all. His philosophy was simple: if you want results, stop asking permission. Through him, America invented a new way to invent, one that remains the foundation of American technology today. The war created the system that led to computers, the space race Silicon Valley. War shaped not just history, but the future. Radar no longer simply watched the sky, and it conquered it. In the early years of the war, radar was clumsy, massive, inconsistent, but American engineers rewired its destiny. They created microwave tracking systems so precise they could follow a single aircraft in the chaos of battle, and guide anti-aircraft guns without human sight. During the V-1 rocket attacks on Britain, those pilotless German weapons screamed over the English Channel like metallic bees. Panic spread because nothing could reliably stop them. Then American radar crews quietly moved into position. With the new targeting system, V-1s that once slipped through now fell from the sky in burnt fragments. What had been a terror weapon became a shooting gallery. And in the Pacific, radar granted American pilots something no one had imagined possible: the ability to hunt in darkness. The Japanese believed night was a shield. The Americans turned it into a killing ground. Pilots launched from carriers in pitch-black darkness. Guided only by radar blips and the faint glow of instruments, they intercepted enemy aircraft, struck, vanished back into the night, and returned safely. Radar removed fear from the dark. It stripped the night of its power. Technology had taken away the oldest advantage in warfare: invisibility. But something else was preparing to replace even radar, something far stranger: machines that could think. In a lab at Harvard, gears and motors clacked like an industrial heartbeat. This was the Harvard Mark I, the first step toward a world that didn't exist yet. 51 feet long, a mechanical monster of wires, pulses, and switches. It solved naval firing calculations that used to require days. Now it calculated them in hours. The machine didn't sleep, didn't tire, didn't doubt. It simply solved. But the real turning point arrived in New Mexico with a new secret: ENIAC, the world's first electronic computer. Ballistics tables that once required human teams and weeks of effort were now produced in seconds. The future was no longer theoretical. It was humming in a sealed room. The war forced the question: what happens when thinking is done not by people but by circuits? The answer would shape the next century. After the war, those same computing principles would build the aerospace industry, banking systems, satellites, and ultimately every. But invention was not only mechanical. It was biological, chemical, psychological. Malaria was killing soldiers at terrifying rates in tropical combat zones. The Japanese did not have a cure. The Germans struggled. America invented a synthetic drug called atabrine. It tasted foul. It turned skin slightly yellow. Soldiers hated it. Commanders ordered them to take it anyway. The pill worked. Malaria incidents plummeted. The war in the Pacific continued. Victory sometimes requires invention. Sometimes it requires obedience. Yet even obedience could not calm fear. The Pacific was a hell of mud, rain, heat, insects, disease, and death. Soldiers needed firepower light enough to carry through jungles. The M1 Garand was already revolutionizing infantry combat as the first widely deployed semi-automatic military rifle. But U.S. engineers continued innovating. They created the M1 carbine, a lightweight rifle weighing barely 5 pounds, firing fast, accurate, ideal for paratroopers, officers, engineers, tank crews, medics. Everyone who carried it praised it. It was not designed for power. It was designed for movement. Speed became the new weapon, but sometimes firepower had to be overwhelming. The United States produced a weapon so terrifying that enemy forces surrendered simply because it entered the battlefield: flamethrowers and napalm. Napalm, a sticky, jellied gasoline that burned hotter and longer than ordinary fuel, could clear bunkers, caves, trenches, jungle fortifications. American engineers had turned fire into a tool. Terrible, brutal, decisive. It burned oxygen from enclosed spaces. It forced surrenders without a single bullet fired. War is not clean. Invention is not gentle. Victory demands what peace cannot imagine. Then came an invention that saved more lives than any weapon took: blood plasma. Whole blood spoiled quickly and required refrigeration. But plasma, the liquid component, could be separated, dried, stored, and shipped anywhere in the world. Plasma saved wounded soldiers in field hospitals, on beaches, and foxholes. It stabilized men long enough to transport them to surgery. It bought time.
Time bought life.
The war forced medicine to evolve, and medicine would never return to what it was. Hospitals today, ambulances today, emergency rooms today, all exist in the shadow of battlefield plasma. Still, the war had more demands. Factories needed efficiency far beyond anything the civilian economy had ever required. The United States invented assembly line mass production on a level inconceivable before the war. Henry Ford's Willow Run plant built B-24 Liberators so fast that a bomber rolled off the line every hour. The plant was so massive that workers used bicycles to travel between wings of the factory. Inside those walls, America turned industry into an armory. War became a numbers game. America learned to count faster, but all the invention in the world required fuel. Oil was the blood of modern war. Airplanes, tanks, destroyers, factories, and all ran on gasoline. The United States had oil. The Axis did not. America invented ways to refine high-octane aviation fuel, allowing aircraft engines to produce more power, climb faster, and engage in high-altitude combat. Higher octane didn't just give planes more power. It gave pilot superiority. American bombers and fighters could fly higher, hit harder, and escape faster. Chemistry became altitude. Altitude became survival. In the labs, new materials took shape. Synthetic rubber became a national emergency when Japan seized Southeast Asia, cutting off natural rubber supplies. Without rubber, there would be no tires, no gaskets, no boots, no wires, no hoses. America launched a synthetic rubber program so large that by war's end it produced more rubber than the entire world had produced before the war. Tanks rolled on synthetic treads. Trucks drove on synthetic tires. Industry adapted. The United States proved that scarcity is not a prison. It is a catalyst. Meanwhile, engineers created self-sealing fuel tanks, rubber layers lined with vulcanizing compounds that expanded to plug bullet holes. Japanese aircraft burst into flames when hit. American fighters did not. A simple chemical property saved pilots who otherwise would have burned alive. The invention was quiet, unglamorous, unnoticed. Yet it rescued thousands. Not every invention was lethal. Some were soft, subtle, invisible to the enemy. The Americans developed heated flying suits, allowing crewmen and bombers to survive at altitudes where temperatures could drop below -50 degrees. Oxygen systems prevented hypoxia. Pressurization systems kept planes from ripping apart as they climbed. Flight ceased being a desperate struggle against the sky. It became warfare above the weather. But the most radical invention of all was unseen. Not a weapon, not a machine, not a material. It was information. The United States turned code-breaking into a science. In a building at Pearl Harbor, American cryptanalysts broke the Japanese naval code called JN-25, allowing the U.S. Navy to know Japanese movements before they occurred. The victory at Midway, the turning point of the Pacific War, was not luck. It was mathematics. Intelligence became foresight. Foresight became destiny. And when secure communications were needed, the United States used the Navajo code talkers, warriors whose language became an unbreakable encryption. They spoke faster than a machine could compute. No Japanese unit ever cracked the code. A language became armor. Every invention, mechanical, chemical, medical, industrial, informational, pushed America forward. Each breakthrough shortened the war. Each discovery saved someone's son, someone's brother, someone's father. War was no longer decided solely by courage or numbers. It was decided by how fast invention could advance. And yet the greatest invention was something immeasurable. The concept that problems are temporary, solutions are permanent. The belief that limitations are negotiable. The refusal to accept impossible as a final answer. This was the true weapon. The mindset that every obstacle contained a blueprint. The United States did not win the war because it had the most soldiers or the biggest factories. It won because it believed every impossible problem could be solved. Every barrier could be broken. Every challenge could be engineered into surrender. A soldier with a rifle is dangerous. A soldier with invention behind him is unstoppable. World War II ended. The inventions did not. They became highways, hospitals, computers, GPS, modern medicine, logistics systems, telecommunications, synthetic materials. The war that forced invention became the world built upon it. Technology today is not merely influenced by the war. It is descended from it. America did not just win a war. America built a future.